Our luncheon speaker is Hannu Kauppinen, and I think you have seen his bio on the website, and you have read it many, many times. I don't want to read that anymore because you know that. But I want to tell you a little bit introduction about how we ended up inviting Hannu. I actually invited originally Henry Terry, one of my old friends and favorite professors worldwide. For those of you who don't know, he is like running the Nokia Research Center currently. And also one of his students is the one who did the Linux operating system. He is also the founder of Ekahau, which is one of the leading indoor companies. So, and he couldn't make it. He couldn't make it, and he sent Hannu. So he puts a lot of burden on Hannu for presentation today. This is the story that I wanted to give as an introduction. And with that, with a lot of thanks for you to coming such a long distance. And knowing my background connections to Finland, actually, which goes since 1991, and I had appointment at University of Oulu. Still, I do have for the past 15 years. So I'm very glad and pleased that Hannu is coming here and bringing a little bit breath of Finland into the conference.
Thank you. Thank you, Professor Pahlavan, and thank you for inviting me to this very interesting workshop. This is the first time for me, and I will certainly attend the next one in 2 years' time. And greetings to everybody from Henry Tirri, my boss, head of Nokia Research. He could not make it this time because he had to attend management meetings in Nokia, so that's why he sent me. He sent me, but we certainly work together in many of the areas that I present here today. And I have been working with Nokia for 14 years now, and I have a long background in research, and I was actually for 2 years' time I was heading Nokia's wireless research, but then I became more interested in the commercial aspects of the technologies, and nowadays my responsibility is to commercialize all the new technologies from Nokia Research. And the topic of my speech today is consumer applications of indoor and local positioning technologies. I will show some of the applications that we have been thinking of. And just a disclaimer first that I'm really working in Nokia Research Center, which is the risk-taking arm of Nokia. So we do a lot of prototypes and pilots, and not necessarily all of these are ending up to products. So just for you to be aware of that. And I will show a short introduction to Nokia Research Center and discuss what are the research questions regarding indoor and local positioning from Nokia point of view. Then I will actually show 3 cases, research projects we have been working on, and they are called Nokia Find and Connect, Nokia High Accuracy Indoor Positioning, and Nokia Instant Community, and then present a short conclusion. But first, a lot of people have been asking from me that what is Nokia Research Center and what is it doing. So we are a global network of almost 600 researchers and research professionals. And we have laboratories at 12 different sites in the world, ranging from Berkeley and Palo Alto, Hollywood on the US West Coast, all the way to Beijing in China, and then several locations in between. And we do have large labs in Helsinki and Tampere in Finland, but more and more nowadays it's really a global network of almost equally sized laboratories. And then we have been paying special attention on the technology transfer from research to business. So we are not an ivory tower within the company, but we really want that our visionary ideas and technologies end up to products. So that's why we built two special teams, one of which is called Advanced Systems Engineering, who develops prototypes and product level implementations. And then the other one is Business Validation, which is my team, which is then driving the products towards commercialization. And then we of course have strategy, very strong strategy teams and operational excellence team. And we're part of Nokia's corporate development organization. So here is the new organization chart of Nokia. Actually, it's so recent that it's only going to be valid in 2 weeks' time as of July 1st. So these big companies, they change their organization all the time. So this is not even the truth yet, but it's going to be in July 1st. So we have 3 major business units, one called Mobile Solutions, which combines smartphones and mobile computers and services. And then another one which is called Mobile Phones, which contains the kind of the basic phones. And these two businesses are very different businesses, so they need to be in different organizations. And then we have markets, which is responsible for manufacturing, sales, and marketing of the devices. Then we have 2 separate companies within the company. Navtech is the company in its own separate map business, but very importantly providing the map content for our devices. And then Nokia Siemens Networks, which is a joint venture between Nokia and Siemens. So altogether, about 60,000 people work in Nokia, the mother company, another 60,000 in Nokia Siemens Networks, so altogether like 120,000 employees. And then NRC, Nokia Research Center, is there part of the corporate development, actually not in such a corner there, lonely, but very much interacting with all the operating units in Nokia. So we really have a good visibility to the businesses and products of all these units. And Nokia produces about 400 million devices every year, which is almost 40% of the total market. Okay, in Nokia Research Center we have 4 different research focus areas, such areas where we believe that we can be leading in the world, but at the same time they are important for our company and our industry. And the areas are called rich context modeling, new user interface, high performance mobile platforms, and cognitive radio. And then all of these areas are approximately of equal size within our research center. And then many of the applications based on top of the enabling technologies from these areas actually require components from these different areas. So actually when we talk about indoor location, it is about modeling, it is about user interfaces. You need the radio, and you definitely need several components from the mobile platform. But these are our focus areas. And then a few words about indoor and local positioning from the mobile devices perspective, and this has been covered in some of the speeches today. But as we know, these mobile positioning technologies, they were really widely researched and developed during the 1990s and even earlier than that. And then they became commercially deployed in the form of mobile location-based services during the 2000s, especially during the latter part of the last decade, because several enabling technologies came together. The positioning technology was power efficient enough, but you also started to have digital maps and good connectivity and so on. Now, similarly, we think that the same is going to happen to indoor and local positioning technologies for mobile devices, whether they are based on networks or they are some other real-time locationing systems. And these technologies were extensively studied during the last decade, and now we believe that the time will come for them to be commercially deployed. Then we have still all these technical questions that what are the best technologies for mobile usage from power consumption and accuracy point of view, what kind of infrastructure is needed, and what kind of standards are needed. And then, more importantly, we have the business questions. For example, what are the killer use cases, and what are the business models for these services beyond the vertical solutions. So, for example, advertisement has been mentioned today as a business model. And then, what are the business ecosystems for indoor and local location-based services? What are the different players needed in the value network? Okay, so then I will go to my first example, which is called Nokia Find and Connect, and you will find many components within this idea, components which have been discussed today in several presentations. So we wanted to do indoor location-based services and applications in the enterprise context, and we picked a very challenging environment, namely our Nokia Beijing campus. So like 2,000 people work in this building here in the photograph, and the objective was to build a mobile social networking platform that links physical resources with online social networks to provide real social networking. And so this is how the building looks like outside, and here is an interior view. And those of you who are experts in positioning technologies, you see that this kind of a mix of large open spaces, open offices, corridors, and small rooms provides a very challenging territory for deploying positioning systems and services. And we actually deployed the system only in one floor, so we used a commercial Wi-Fi positioning system by using the existing wireless LAN network, and we built our own research backend system and Symbian S60 client for piloting these solutions. And even though there's several hundred workstations in this floor, not everybody used the service in this one floor, so we had like 100 clients actually going around in the building and using the service. So the questions that we posed are then familiar to everybody who works in this kind of buildings, that the meeting rooms are booked but are not being used. I cannot find a meeting room available online. I cannot find my teammates in the building. I cannot find where the meeting room or printer is, and I cannot remember where I have met with him or her before. So this is how the application then looked like. So the examples you saw in the video were about finding people first example was about identifying a person, then based on location. Then the second one was finding a person. Then it was about finding desk, finding rooms, and finally finding equipment like printers. And these are the applications that we have all been talking about. And you saw the interface on the mobile phone, and so you saw that it's actually not that user-friendly, which proves that it's a real research prototype. So we did all those applications, and then actually the research project then turned to another direction, which was then about understanding more about the social relationships between people, and then this system is still being used for that. But then the interesting, and by the way, this research project was initially called Mobile Workplace Helper, but then it became the Nokia Find and Connect, because then actually our IT department became very interested in that, and now it's being piloted in several Nokia campuses all over the world. So it's very clear that with this kind of system you can improve companies' internal efficiency because of all of these benefits, and it's definitely a solution that interests corporate IT departments, and then could be used and deployed by them. Now, corporate IT systems are not exactly the business of Nokia. We want to use them, but not necessarily sell them. At least for now. But the good news for you guys is that there's definitely need for this kind of systems, and it's fairly easy to build them. So that was my first example. Okay, then I want to show another example of our research, which we called high accuracy indoor positioning, with the abbreviation HYPE. And then you may argue whether this accuracy is high or not, but definitely the acronym HYPE sounds good for us. Really, we think that the indoor positioning clearly starts from exploiting Wi-Fi. So the benefit is that we can use the already existing and installed wireless LAN networks. The accuracy is not always that good, especially in the open areas, because you don't have that much variation in the signal strength, in the fingerprints, but it's certainly applicable for cases in which room or area level accuracy is required. So, for example, in the case of Nokia Find and Connect, the Wi-Fi positioning system performed very well. But then, like it was then discussed in the latter part of this morning session, maybe in some cases the better accuracy is needed, or even if it's not needed, then users start to require it. And we developed this high accuracy indoor positioning research prototype, but we decided to use a standard technology which is coming into our phones anyways, and then we picked Bluetooth low energy, which is then coming to normal Bluetooth mobile phones, but then this low energy mode will be used for such applications which require very low power. And then the advantage is the very low power consumption, and of course also the low latency. So there's no need for connection setup, or even if we set up the connection, the connection setup is extremely fast. And then we use beacons, and we actually use directional beacons in our prototype. And here is the system description. So we have these directional beacons providing the good accuracy. Then we have these micro beacons to fill in the gaps where in areas where we cannot use the directional beacons. Actually, we can use Wi-Fi access points as well. And then we have a server running the positioning system, and then we need to have a beacon database. And then this system can use either mobile devices when we have the chip in there, or it can also use tags. And because this Bluetooth Low Energy has a very low power consumption, then the battery life can be, even in this kind of a very small tag, it can be up to 2 years. And in bigger tags, the lifetime can be longer. And the principle of this system is really that it uses direction finding. So when you have one single directional beacon there up in the ceiling, it's a little bit like having a satellite up there in the sky, but this uses beacons in the ceiling, and the beacon sends the directional signal to the mobile. And when we have one of these beacons, and then we know the height difference of the beacon and the device, then the mobile device can resolve its location in 2D. And of course, it also works the other way around. It works also in the uplink direction, such that the mobile or the tag can send the signal and the beacon can receive it either way. And when you actually have 2 of these beacons, then you don't need to know anything about the height, but you just resolve the full 3D position. And we tested this kind of a system in the lobby of our office building. So we mounted 2 of these positioning beacons on the ceiling, and the height was about 20 meters. And there's some result of walking around this auditorium, and the system actually works in the auditorium as well, because the ceiling is wooden. And the positioning error was less than 1 meter with 50% accuracy, and then less than 2 meters with 90% accuracy. And this was only with this positioning system or this direction finding system alone. But then when we later on added accelerometer and used inertial navigation, then the results were much better. But then this is actually, this 1 meter is still not that convincing when you are speaking of high accuracy. Interesting property of this technology is that the accuracy scales with the distance. So the shorter the distance, then the smaller the angular error, and then better the accuracy. So within a room, you could have like a 10 centimeter accuracy, but if you actually have some ambiguity with the height of the device, then you can probably guarantee like a 1 foot or 30 centimeter accuracy. And actually the beacons nowadays look like they're flat design, and they look almost like smoke detectors. So they are indistinguishable from any other infrastructure in the buildings. And when we thought about all these applications that this kind of a higher accuracy could then provide, then obviously we were thinking about applications in retail, sending guidance to find items, then sending special offers, getting targeted ads, and so on. And there are other applications and other pilots we're going to do in other environments, such as airports, again providing efficiency, being able to provide navigation aid, but then on the other hand also measure length of line and how fast the lines are proceeding. And finally, then my favorite application in this area is to bring it to a sports arena, and actually it works pretty efficiently. In this kind of environment, you can cover a whole arena with one beacon only, and then the audience can find where the friends are sitting. But then with the same system, you can actually track positions of the players. And we even tested that the tag can be put inside the puck, so it tolerates the impact. Okay, as you can see, this is very visionary and still early research. But if you think about these kind of systems where you need this new technology and new infrastructure, you would need to have all these pieces in place, you would need to have mobile devices supporting new technologies. Well, that part we have it, because as Nokia we can deploy new technology in our devices. But then you would also need to have this kind of a positioning infrastructure, which is cheap, easy to install, low maintenance, which is the tricky part. And then you need to have all these maps of the areas. Well, that kind of gets solved, because everybody wants to provide those maps for these buildings. And then you need those services and solutions. And currently these indoor LBS systems they are more based on vertical applications, like the ones which I showed in the first example, but they are not really consumer applications. So we really need to demonstrate the consumer benefits, and therefore, if the consumers are interested to have this kind of systems, so then probably advertisement-based business models could be used. Okay, I hope I have time for the last example still, which is called Nokia Instant Community. And this goes one step further away. And here we are not using any infrastructure at all. And we want to provide a close location user experience and the new era of connected communities. And if the research question for us was that, how do I connect people locally in the physical world, in this kind of environment where we don't necessarily have lots of infrastructure, or the people don't know how to log in to those systems. They don't have any idea about any systems in there. So there we took a different approach, and there we decided to use ad hoc networks, mesh networks, and the main features of the Nokia Instant Community is that you can create location and context-based networks between people and places. It's automatic. There's no user actions needed. You don't need to switch on anything. You don't need to log into anywhere, and then you can know who or what is close to you. And the technology behind this is based on Wi-Fi. So we use direct Wi-Fi connections between the devices. So we don't use any base stations, but this is a special implementation. It uses a low power protocol by using the wireless LAN radio chip, and we use the chip in a very energy efficient ways, enabling several days of battery life. So you don't even notice that the wireless LAN chip is on, because that's really the kind of the bottleneck of Wi-Fi systems nowadays, that the Wi-Fi chips uses so much power. So we solved that part by tweaking the technology. And then the application examples are, for example, finding how many people are close by, and if necessary, finding who they are. We can start group communications automatically. We can start chatting, sharing images and videos. We can find our friends, Facebook friends, from if they are nearby, and we can, of course, then receive navigational help and information from places close to you. And now this is when one of these nodes would actually be fixed. And again, I'm showing you a video of some of the use cases here. And as you can see, this was again shot in a different country. So the story had a happy ending, as you might have guessed. We actually have another application tried out in the same country, India, in rural areas where you don't have network connectivity and where you have lots of different opportunities. But I decided to show this fun application. So the key point of Nokia Instant Community is that you can recognize other Nokia Instant Community devices in the vicinity. It's total device-to-device communication. You don't need to log into anything. You use this very low-power Wi-Fi mode so that you can keep it always on. And why is this related to positioning? Well, people who are close by to each other, they inherently then form a location-based system. And the positioning accuracy in this kind of network is roughly 20 to 30 meters. So actually based on the signal strengths, and if we do ranging still on this on chip, we can actually determine the topology of the network. We didn't try, but we simulated that the system scales up to 100,000 users locally. So in a stadium picture, which you saw in the beginning, those 100,000 people can be reached within 5 minutes. So if you send a message, then everybody receives it in at least 5 minutes time. So this is really a platform for lots of new applications. And we are piloting it among 300 students in Finland, in Tampere University of Technology, and they are developing new applications on top of this platform. Okay, so I have a couple of conclusions here. First one is that you really need a hybrid use of positioning technologies. You need to use the existing ones, and then you can develop new ones for new purposes. And you need to show the consumer benefit in order to justify large-scale deployment. Maybe for in some cases it doesn't go that way. In some cases you first do the positioning system, and then afterwards people develop applications on top of it. But especially if you need to deploy any physical infra, then that needs to be commercially justified. So we continue the search for viable business cases in this area. Having a large mobile device base helps if your mobile phones support the technology and the applications. And then indoor maps are a key enabler, which we haven't talked about so much today, but as we all know, navigation started from first having maps, and then you started to have the technology on top of that. So the maps is really a key enabler. Thank you for your attention. There's a couple of links, research.nokia.com and conversations.nokia.com, where we show actually these same technologies and many others. And I hope you enjoyed the presentation.